Hello everyone. Today we will look at solving lead code problem number 4, median of two sorted arrays. We will look at three suboptimal approaches which is intuitive to solve the problem. All these three approaches have been accepted by lead code. In upcoming video, we will look at optimal approach to solve this problem. Let's look at the question. Given two sorted arrays nums1 and nums2 of size m and n, return the median of two sorted arrays. The overall runtime complexity should be O of log of m plus n. We'll ignore the runtime complexity for all the three suboptimal approaches that we'll be looking at today. In future, we'll look at a solution that satisfies this runtime complexity constraint. Let's look at example test cases to understand what does the median of two sorted arrays mean. In example 1, nums1 is 1, 3, nums2 is 2. The output is 2 because if you merge the two arrays in nums1 and nums2 and sort it, it will look like this and the median is 2. Let's look at example 2. Nums1 is 1, 2, nums2 is 3, 4. Output would be 2.5. This is because when you merge the two arrays nums1 and nums2 and sort it, it will look like this and the median would be 2.5. Let's think about an easy solution to solve the problem by taking this example test case where nums1 is 5, 9 and nums2 is 2, 7. The most intuitive approach that comes to beginner's mind is merge and sort approach. In this approach, we merge the two input arrays into one and then we sort the merged array. Because the sum of the length of input arrays is even, we return the average of middle elements, which is 6. Let's look at the solution for test case where sum of length of input arrays is odd. Nums1 is 5, 9 and nums2 is 2. We merge the array and then sort it. Because the sum of the length of input arrays is odd, we return only the middle element. This is the code of solution of merge and sort approach that we discussed. At line 3, we merge the two input arrays in one. At line 4, we sort the merged array. And then, in if block, we check if the length of the merged array is even, then we return average of middle elements. Otherwise, in else block, if merged array is odd, then we return only the middle element. This solution is accepted by lead code. The code link will be in description box below. Let's do a time complexity, space complexity analysis of our code. The time complexity would be O of m plus n into log m plus n. This is because of computing merged array which takes O of m plus n and sorting which takes m plus n into log of m plus n. Here m and n are length of nums1 and nums2. The space complexity of the code is O of m plus n because of storing nums1 and nums2 in merged array, and sorting operation also takes same space complexity. Let's look at approach number 2, which is better than approach number 1 in terms of time complexity. We will call this approach as merge with sort approach because we merge and sort the array in one operation. This approach is based on merge operation of merge algorithm. This can come to your mind if you can relate the problem to merge sort algorithm. Let's look at how this approach works by taking this example test case where sum of the length of the arrays is even. We start by initializing the ith and the jth pointer to index 0 of nums1 and nums2. We append the smaller element of the 2 in merged array, which is 2. We increment the pointer of smaller element chosen, which is jth pointer. We append the smaller element of the 2 in merged array, which is 5. We increment the pointer of smaller element chosen, which is ith pointer. We append the smaller element of the 2 in merged array, which is 7. We increment the pointer of smaller element chosen, which is jth pointer. Because the jth pointer reached end of nums2 array, we will add all the rest of the elements present in nums1 to merged array, which is only 9 in this test case. Now we completed our merged operation. We will return the average of middle elements in merged array, which is 6. This is the code of the solution. The while loop creates the merged array with sorting. And then we have the if and else block, which is similar to the previous approach, where if the length of the merged array is even, then we return the average of middle elements. Else, if the length of the merged array is odd, then we return only the middle element. Let's do a time complexity space complexity analysis of our code. The time complexity would be O of m plus n because of while loop to iterate both the arrays. Here m is length of nums1 and n is length of nums2. The space complexity is O of m plus n because of storing nums1 and nums2 elements in merged array. Let's look at approach number 3, which is space optimization of previous approach number 2. We will call this as optimization of merge with sort approach without merging. This approach 3 is better than approach 2 in terms of space complexity. In terms of time complexity, this approach 3 is slightly better than previous approach number 2, but the time complexity of both approach number 2 and approach number 3 is linear. In previous approach, we merged the two arrays in one, but in this approach, we don't merge the two input arrays but iterate the two arrays in same way as we did in previous approach number 2 to find the median based on the target index. The element at target index will be of interest. Let's visualize the solution by taking this test case where sum of length of the input arrays is even. We'll start by initializing these variables where target index would be length of nums1 plus length of nums of 2 divided by 2 plus 1, which is 3. Previous element, current element and count will be initialized to 0. Ith and jth pointer will be initialized to index 0 of nums1 and nums2. Previous element will be updated to current element, which is 0. Then we update the current element to smallest of the two elements that ith and jth pointer are pointing to, which is 2. The count will become 1. We increment the pointer of smaller element chosen, which is jth pointer. Previous element will update to current element value, which is 2. We update the current element to smallest element of the two elements that ith and jth pointer are pointing to, which is 5. The count will become 2. We increment the pointer of smaller element chosen, which is ith pointer. Previous element will be updated to value of current element, which is 3. We update the current element to smallest of the two elements that ith and jth pointer are pointing to, which is 7. The count will become 3. Now, count is equal to target index, which means we have found our element at target index, which means that at this point the values of previous element and current element represent the middle elements in merged sorted array. So we return the average of previous element and current element, which is 6. This is code of approach number 3. We have a for loop which directs the ith and jth pointer increment same as approach number 2. This for loop helps identify the element at target index. And then we have if else block, same as previous two approaches, where if sum of length of input arrays is even, then return the average of middle elements. Else, sum of length of input arrays is odd, then return only the middle element. The time complexity of this code is O of m plus n divided by 2 plus 1. This is because of the while loop that we use to iterate both the arrays. The space complexity is O of 1 because we are not using any additional storage. All links to the code snippet can be found in below description box. In next video, we will look at optimal approach. Thank you for watching and stay tuned.